All right, welcome. This is 1.3 Solving Quadratics. Again, this is a review from last year. We spent a whole unit talking about solving quadratics. So just a reminder that all quadratics have a degree of 2. It means the highest exponent is a 2. That means that there will always be 2 solutions. They could be real or complex, meaning we have imaginaries. All right. We also talked about 4 different ways to be able to solve a quadratic. And we're going to focus more on these first 3. If you remember completing the square, great. You can use that on some of the problems that you can't factor. But we will focus on factoring, solving by using the quadratic formula, and we can use square roots to solve if there is just one term with x's that's squared. All right, so let's just get into an example. So here, this problem is already factored. So if you remember, we talked about something called the zero product property. So the zero product property basically tells us that if we have something equal to 0, that's the 0 part of the zero product property, and we have 2 things that are being multiplied, then we know something. We know that either A has to be 0 or B has to be 0, or both could be 0, right? So again, that's what this comes from, is the zero product property. Okay, so if we go and look at this example, we have 2 factors that are being multiplied and they're equal to 0. So that means that either our first factor, x plus 3, has got to be equal to 0. So if that's 0, if this whole thing is 0, then the whole equation is going to be 0. And then same with the other factor, x minus 8 would have to be 0, because if that's 0, then the whole equation will go to 0. Okay? So once you get to those 2 factors, all you need to do is you need to just set each factor equal to 0 and solve. So that's what we got. We got those 2 factors equal to 0, and we just need to solve. So this one's really not too bad. You probably could do kind of find out the factors, or the solutions without solving. Okay, so we'd end up getting x equals -3, comma 8. All right. I've also had to say, so are we just like changing the sign of these constants? And you can kind of think of it like that, but really what's happening is, again, we're trying to figure out what x needs to be for that factor to go to 0. Okay, so the x would have to be -3, and this x would have to be a +8. Okay, so that would be our solution. All right, let's try another example. Okay, so this one is in standard form. If we're going to solve by factoring, then we're going to need to factor. Okay, so this is where we find the 2 things that multiply and add. Multiplies to 6n squared and has to add to the middle term. Okay, so think about that. Our only choices are 1 and 6 or 2 and 3, and it looks like 1 and 6 would work. So we could do -1n and a -6n. Okay, since this equation is a is 1, we call this monic. If a is 1, then we can just write our 2 factors. So we'd have n minus 1 and n minus 6. Okay, and then we can do the zero product property. We know that, well, you could probably do this without writing anything, but we'll just do it anyway. So n minus 1 equals to 0, and n minus 6 is equal to 0. So if we add 1 to both sides, we'd get n equals 1. And if we add 6 to both sides, would get n equals 6. Okay? And on your homework, most of the time, it's going to ask you to write it as like or write our solutions separated by commas. So something like that. Okay? If you're ever sure, we could always take these solutions and we could plug them in for our variables, and it should give us our answers. Okay? If you did it correctly. All right, so here's one more or a couple more examples. This one, we won't be able to go straight to the factors once we find the two things that multiply and add. Why? Because A is not 1, okay? This is not monic. So here what we'd need to do is we would do our puzzle. What multiplies to 2x squared times 6, so 12x squared, and adds to the middle term. So let's think about that for a second. If we're stuck, we could always write down factor pairs. 1 and 12, 2 and 6, 3 and 4. It looks like we would need to do -3 and -4. So again, those are not our factors. We're not going to do x minus 3 and x minus 4. If we were to do that, probably don't want to write this here, or you can, but we're going to cross it out. If we were to distribute that back, we would end up getting x squared. But as you see over here, it's not x squared, it's 2x squared. Okay, so that's why we have to factor by grouping. We're going to use a box. Probably did this last time in class. Okay, so again, our first term is our first box, our last term is our last box, and then our puzzle, our factor pair will give us our other one. Okay, so then we will factor out the greatest common factor for each row and column. Looks like we've got an x and -2, and then 2x and a -3. Again, we can always check by multiplying back to see if it matches, and that looks good to me. So we'll have 2x minus 3 and x minus 2 is equal to 0. And now we just got to use the zero product property. So either 2x minus 3 has got to be equal to 0, or x minus 2 has got to be equal to 0. And then we'll solve. So on the right side, that one's pretty easy. We could just say that x has to be 2, right? That would make it equal to 0. For the other one, I would highly recommend that you actually do the steps. So here we could add 3. Here we're just doing like the opposite of PEMDAS. We add or subtract first. So we get 2x equals 3. And then our last step would be to divide. Why? Because it's 2 times x, so the opposite of times, divide. Okay, so this is our other solution. We've got 3/2 and 2. All right, hopefully that one's okay. And then let's do this last one. So this is a little different. It's not like the other ones we've done. We can't factor by grouping, but we can do a different type of factoring. I always tell the students, what do you got to do first? What do you got to check for first? Okay, and we should always check for the greatest common factor. So if you look in both of these terms, there is an n in both terms, which means we can factor out an n. And then to figure out what's left, if we divide everything by n, we'd get n minus 7, and that's equal to 0. Okay, so this is fully factored. We didn't have to do the puzzle or box, factor by grouping. We were just able to just factor out that greatest common factor. I'll put a little star, greatest common factor first. Okay, so now we do the zero product property. So either n has to be equal to 0 or n minus 7 has to be equal to 0. So then our two solutions would be 0 or 7. Again, we could just add 7 to both sides to get n equals 7. All right, so that is factoring, or solving by factoring. Let's go look at the quadratic formula. So just a reminder, this is the quadratic formula. It's a little beast. If you take your equation in standard form like this and you complete the square, you would end up getting the quadratic formula. And if you want to give that a try, that's always kind of fun to do. Okay, so just make sure your equation is in standard form. A, B, and C in the formula is just the coefficients. So we shouldn't be plugging in any variables, just the coefficients. Okay, so let's just get into a problem. I'll keep that there so you can see it. All right, so first off, identify A, B, and C. So what's A for this example? Well, I've had students say, oh, it's x or x squared, okay? What is the coefficient? What's the number that's in front of that x squared? It's a 1, right? So here A would be 1, B would be 4, and C would be -9. So make sure you get the signs as well, not just 9, but -9, okay? And then we're going to substitute. So we're going to do x equals -b, b is 4, plus or minus the square root. Please use parentheses when you substitute here. 4 squared minus 4ac all over 2 times a. Okay, so why do I say parentheses? Is because sometimes people run into issues, especially if, like, let's say, example, if b was -5, okay? If you plug this in and you didn't use the parentheses, so you just did something like this, your calculator is only going to square the 5. So it's important, this is not the same as this, okay? So make sure you use parentheses. Also, sometimes people will forget if we were to plug that in here. Remember, it's -b, so -5. Okay, so that's just, again, as an example. We'll see, maybe we'll run into a problem that has b equals negative. I don't think any of them are here. So just be aware of that, okay? All right, now let's finish up with what we're actually doing, this problem. All right, so we have our solution. This is our solution, okay? We just need to simplify it. The first thing we're going to do is simplify what's called the discriminant. And the discriminant is the inside part of your formula, okay? So we're just going to put that into our calculator. When you do that, oops, my bad. When you do that, we're going to end up getting the square root of, that's probably a little too big, 52. Okay, so what the discriminant is very helpful. It will tell us what types of solutions you're going to see. Okay, if you get a positive for your discriminant, sorry, got stuck there for a second. If the discriminant is positive, then you are going to have two real solutions, okay? If it's something like the square root of 52, that's not a perfect square, so you're going to end up having irrational solutions. If you end up getting a discriminant, well, we'll get into that for B. If you get something like the discriminant is 16, well, now you know what the square root of 16 is. That's going to give you a really nice answer. So your two solutions will be rational, meaning no roots left, okay? And then if the discriminant is 0, then we don't have the plus or minus part, right? It's just plus or minus 0 isn't going to change anything. So you're going to end up having one solution, okay? And if you get a negative for your discriminant, so what's inside is negative, you're going to end up getting a complex solution, meaning we'll have like imaginary in it, right? All right, so let's finish this up. Sorry, I probably got on a tangent here. Okay, so here, we can't do the square root of 52 it's not a nice number, right? So either you have to have a calculator that can reduce a square root, or we have to simplify by hand by doing a factor tree. So here we could do 2 and 26, 2 and 13, and then 13 is prime, so we can't do anything with that. Again, we want to find groups of 2. Why? Because like 2 times 2 is just 4, right? So we're doing the square root of 4, which means we can take out a 2. The 13 can't be simplified. We don't have a group of those, so it has to stay inside. And again, this 26 that we have here, that's the 2 and the 13, so you can't use that again, okay? So just in case you forgot how simplifying roots goes, okay? All right, and now we want to see if we can simplify the fraction. You see we have this crazy fraction, okay? We want to see if we can divide all 3 of these numbers, okay? So we can divide them all by 2. So we should end up getting -2 plus or minus 1 square roots of 13. And we don't need to have that 1 in there, so this would just be our solution. Okay, those are our 2 solutions. All right, so that's the whole process. Identify, substitute, simplify the discriminant, simplify the root if you can, sometimes you can't, and then see if you can simplify the fraction. All right, let's try another one. So here we have A is 2, B is 3, and C is 5. And we are going to substitute that in. So x equals -3 plus or minus the square root of 3 squared minus 4ac all over 2 times a. All right, so again, we're going to do the discriminant. We'll end up getting, when you type that in, again, that's probably a little too big, we'll have 49. And then, like I said, the discriminant is a perfect square. The square root of 49 is 7. Okay? So please make sure that once you square root, you don't have a square root anymore. I've had lots of people like say that this is correct. Okay, so watch out for that. After you square root, there's no root. All right, so then we just need to find those 2 solutions. These are actually nice. These are all the same type of number. They're all rational, which means we can actually add and divide these numbers. Okay, so -3 plus 7 is 4. So 4 over 4 is just 1. So that's one of our solutions. And then -3 minus 7 over 4 is -10 over 4, or -5/2. Okay? So those are our solutions. I should maybe mention this, okay? So when we go back to this example where we had the square root of 52 over 2, and we had -4 plus or minus, okay? I've had people try and do this, okay? They've tried to do something like this. They say, oh, well, 4 divided 2 is -2 plus or minus the square root, and, oh, 52 is even, so we can do, what, 26, okay? And then they try and see if they can simplify the root, okay? So we cannot do that. You could do this part, but you can't do this part. And I think if you tried to do that anyways, it probably cause issues. But the reason why is if we have the square root of 52 over 2, this numerator isn't 52, right? It's the square root of 52. So if it's like, I don't know what that is. It's probably like 7 point something something forever, right? It's close to 49, so it's close to 7. The square root of 49 is 7. But we can't divide something that's in a root by something that's something outside of the root. Does that kind of make sense? If you were to divide, they both would need to be in a square root. So that would give us the square root of 26. Okay? So just be aware of that. All right, so last example. Let's do this one. So x equals negative 11 plus or minus the square root of 11 squared minus 4 times 1 times 18 all over 2 times 1. Okay, so then we want to get that discriminant. Actually, I haven't looked that one up yet. We haven't done this in class, but I just wanted to do it anyways. Okay, so I'm just putting that in. Actually, we're going to just skip this one. I think this one is very similar to what we already did. Yeah, let's maybe just skip this one. Yeah, I think this one's factorable as well. So it's very similar to B. All right, so let's go into solving by using square roots. So if you have, so look at all these. There's only one term that has an x, and they are squared. So that means that we can just go backwards through PEMDAS and solve for x. So PEMDAS again, PEMDAS. Okay, we're going backwards, so add, subtract first. There's no adding or subtracting for this example. Multiply, divide. This is multiply, so we're going to divide. And then exponents. We want to get rid of our exponents, so we will square root both sides. And don't forget that when we square root both sides, we'll have a positive and a negative version of that square root, okay? Like if you look at it how it was originally like this, 3 or negative 3 would satisfy this equation, okay? So here we'll get x equals plus or minus 3. All right, let's try another one. Same sort of step. Divide. We'll get negative 5. We'll square root, just the same. But here this is a little different. When we have a square root with a negative inside, again, that will give you an imaginary. So here we'll get plus or minus I square roots of 5. All right, on your homework, you'll need to separate those with a comma. Okay, and here's another good one. Here you could use the difference of squares if you prefer, but we'll just use square roots to solve. So we'll add. So 16x squared equals 25, and then we'll need to divide. Okay, so we'll end up getting x squared equals 25 over 16, and then we'll square root. So the 25 over 16 can't be simplified, right? So we'll just have to leave it how it is, but we can square root the numerator and the denominator separately. So we'll get plus or minus 5 over 4. Okay? And you'll get the same answer if you factor instead, using difference of squares. All right, last example. This one would subtract 18. So again, we're going to end up having an imaginary when we square root both sides. So this one, I think you can actually simplify your root, and we can write an imaginary, an I. So here we have 2 and 9, 3 and 3. So we'll end up having plus or minus 3i. Square roots of what's not in the group is just a 2. All right, so just a quick reminder of what we covered. Factoring works great if you can find the two things that multiply and add. It will save you some time if you can realize that. But don't ever spend more than 60 seconds trying to find the two things that multiply and add, because otherwise you could spend forever trying to do it, when you can't even factor it, okay? Square roots work great if there is 1x in the equation and it's squared. And then the quadratic formula works all the time. You have to memorize the formula, and sometimes you forget to put parentheses and you could get mistakes that way. So you just have to be careful when you use the quadratic formula. And also just a quick reminder too is that many of these, like factoring and the quadratic formula, they need to be in standard form. Otherwise, it won't work. Okay? All right, well, we'll see you later. Let me know if you have any questions.